Hello everyone and welcome back to this Python programming series. So I hope everyone is clear until the typical hello world code on the Jupyter lab as you can see on the screen right now. If not, go through my last video again where we talked about the basic installation of Python, the installation of Python using Miniconda 3, the environment, how to set up an environment in Python, why environment plays an important role in it, various keywords and identifiers, various nuances related to it. The link to the previous video is given in the description. If you want to explore it in more detail, you can click on the link in the description below for the previous lecture. So moving on, in this lecture we'll be basically covering the indentations, how values are assigned in variables, how different types of values are assigned in variables, and in which ways it can be stored. So it can be stored in various ways, like it can be stored in a list, in an array, in a data frame, in a tuple, in a dictionary, and different kinds of stuff. Also, different types of values. It can be an integer, it can be a float, it can be a string, anything it can be. So in the last lecture we did see assigning a value to a variable value 1. Now if I print value 1, value of value 1 variable is 2. What is the type of this variable? For that I'll just write type bracket value 1. I'll just get it is an integer. Let's assign a float value. Float value will mostly be something like 2.5. So let's take it and some different variable. That's a value 2, right? 2.5. Now if I see type of value 2, I'll see float. Right, now third one is value 3 is equal to. Now strings are always written in quotes. It can be double quotes or single quotes, but Python will take it as the same thing. Right, now I'll just write something like Python is great. When I see value 3, it will me. Now when I see the type of it, tells me it is a string. Right, see. So those are the three types of values that can be stored.
So now this is a very basic way of assigning values, different types of values to a variable. Now let's see about how to iterate over the same variable and assign different values and update it accordingly. Right. Now let's say I have item 1 is equal to 20, and here 20 stands for 20 rupees. Let's say that is the cost of item 1. Now I just want to see what is my earnings for the day. Let's initiate it with 0 earnings from the day. When I sell the first item 1 on the very first time in the day, I just add it by writing earnings plus 20. So I'm writing earnings plus 20 because my total earnings as of now present is 0, but the cost of item that I've sold is 20. So when I write it, it will be 20, but I just want to assign it to earnings because my total earnings right now is 20 and not 0. Because when I see back earnings, it will be again 0 because I'm not assigning any value to earnings back. So I'll just write earnings is equal to earnings plus 20. Right, now when I print, it will be 20 rupees. So this very line can also be written in the way earnings plus is equal to my item 1. Right, now when I do this, it will be same as my earnings. This is my earnings. See, it has gone to 40. Now I just don't have to write earnings plus 20 or let's say item 1. Instead I'll just write this thing. It just saved your space. So what Python understands from this is you just add earnings plus item 1 and save it in earnings as well. So when I again run this thing, it will just provide me 60. See, the next thing 80, next thing 100.
And the similar arithmetic operations can be done in the same case. So if I take the subtraction thing, I can also do that. Item 1, and if I say earnings, if I multiply it by that,
from that. See, the only good fact about this is, and the unusual one is, if you divide it, its data type changes. So if I do something like this, right now if you see this, the type of this would be integer, right? Now if I do this, it changes to float. Now that happens because we are doing division over here, and when we do division, Python always does divisions in floats, right? So this is an iterative process. You can do n number of times that you want. You can just add it in a loop, a for loop or while loop, that will be going through in the upcoming lectures. So yeah, this can be done. This is how you assign values, different types of values and variables. Now if I want to add string values, what I need to do is, so I'll just say variable a, I'll just assign this is pretty good. Now one more thing about saving, see, this is pretty good. Now one more thing while saving in strings is, you can add anything over there. So I can add a number probably. See, a value can be assigned. So when I check the type of this variable, it will always be string, not float or integer. So when you save anything in codes, it will always be a string, irrespective of whether you store an integer value or a float value inside a string. It will always take it as a string, right? Now, how will I print if I want to add two things in that thing? Let's say if I want to say, so if I want to add this is, now when you, let's say I want to add the value of items, you cannot directly write just item one variable name says the things I had today. Right now, item one. Now, this is not something that you can do in Python. It would consider it as a string. Now, when I want to print in it, what I can do is take this thing and do this thing, assign this thing as a function. I'll just write f and Python, that inside the code what I'm writing is either a variable or some value. When I do this, see, it went to the value of item 1, which is 20. Right? So this is how it is done. This is how the values are assigned. These are the three types of values that can be assigned. Alright. Right. Now this all things that we learned about is basically an assignment statements. All of this that we have written so far. This assigning, this is pretty good in A, 789, the values, the rates, the integer, the floats, everything. This is called the statement, the assigning statements. Now there are different statements called as the for statement, while statement, different loop statement, etc. So that we will be discussing later on. Now there are two types of statement. This is a single line statement that will be written. Now there can be a statement where I am taking, where it can go pretty long, and I'll need to write it in multiple. So if I assign values like, let's say I even add things like this, a plus 2 plus 3 plus 4. If I want to make it much more clear, I'll just add forward slash, and I'll just write 5 plus 6 plus 8, or I can directly write slash plus 9. Right? That's what. So by writing forward slash, by including forward slash in your code, Python understands that there are many more lines that are written down. So in and even in C++, for going the cursor to the next line, we need to write //n so that the cursor went from that particular line to the next line. In a similar way, here Python understands that this is the another line, the code is written on another line, right? One more thing that can be kept in mind is if I want to assign different types of values together in a particular variable, something like a string and a integer or even a float, Python will throw a error because there are different types of errors. You see, cannot can only concatenate string, not integer to string. So in this case, either you have to convert str into integer, which is probably not possible at all, which is not feasible, or else I'll just convert this one into string. So two ways of writing this can be string this str1, or you can directly write 1. Since you have to do all these things in an iterative loop, I'll prefer doing this str1. Right? So here we complete about assignings again, and next we start about indentations, how Python understands that there is a loop going on. So if I write a basic loop for if or else clause where we have written, let's say if a or if item 1 is equal to. Now another difference in Python is when you are using a single equal to, it states as an assignment operator, but when you use double equal to, it understands as that you are doing a comparison. In this case, if I'm saying if item 1 is equal to 10, it can mostly be something like, so I'll just write print true. Now for true and false, you don't need to write it in quotes as it is a boolean value. You can directly write it. Right. So when I print this, it will just directly check. So this is how Python understands that there's a loop going on, there's a condition, and if this condition is true, which is my item 1, if it is equal to 10, you just have to execute this statement, or else you can just directly execute this statement. Whereas if you see in C++ or any other language, the basic version of how a syntax of loop was there was basically something like this, where you can also write the similar way in Python as well. It would work the same way, but it is quite a lengthy way to write. See, it works exactly the same way. If I just change to 20, the actual value of item 1 to just return 2, right? So this is how indentation works, and it works for every keyword that is important that we saw in the very first lecture. After every keyword, you just write a colon, and that is how Python understands that there will be a loop or there will be something like a statement kind of thing that needs to be executed. So we'll understand more about loops in the very next lecture after this. Now my next very important thing would be how the data can be stored. Now as we saw above here, it was just a single variable where the data, different types of data were stored. Now if I want to store it in list defines itself by square bracket. So there it can have different kind of values. Let's say a, it will be shown by square bracket itself. This is what a list looks like. This is what a tuple looks like. This is what a tuple looks like basically. And the last but not the least is dictionary. So dictionary would not just be about values, it would always be a pair of key and values. So as we learned about how to store data in a variable, we can learn in how different formats the data can be stored and how different types of data can be stored in different formats. So the first format that we need to learn is list. Now list, when we say, first of all, lists are something similar to arrays. They are just like arrays declared in any other languages. So lists are one of the most powerful tools in Python. A single list can contain different data types of data. So it can contain strings, integers, as well as objects. List can also be used for implementing stacks, queues, and the most important thing, in the more technical way, we can say lists are mutable. So when I say mutable, it means the data inside the list can be altered. So let's understand it. Let's say I'm initiate a list. It basically signifies, a list can be signified by square brackets. So let's store some values. So it has three values right now. So it can have string, it can have float as well. See, this is how you declare a list. Basically, it can have different types of data types in it. Now, how to access an entire list? If you want to access an entire list, you can just directly call the variable where it is stored. While if I want to access a single value, a single index, while I want to, and if I want to access a single value from a list, I can directly write the index of it, a raised to 2, so it will provide me 3, right? So indexing in Python always starts with 0. So my Python string will always be 0, 0 at term, 2 will be 1 at term, 3 will be second, false will be third, alright? So when I write a of 2, it will always return me 3. So it is a one-dimensional list basically. So indexing can be done in two ways. It can be positive, it can be a negative indexing. Positive indexing, as you can guess, positive indexing begins at 0 for the leftmost first term and then traverses to right. Whereas in negative indexing, it is contrary to positive indexing. Negative indexing begins at -1 for the rightmost last item and then traverses left. To get the same item form list, by negative indexing, we use the index -1, -2, -3. So here, for as an example of positive indexing, I just wrote a of index 2. So I just got 3. That is my third term from the list. Whereas if I write a -1, it will always give me the very last term. That will be false. So, let's say 0. Let's consider like this. 0 term is my Python string. Whereas if I go -1 from that point, it will be false. If I go more negative from it, it keeps on moving from right to left. So let's understand, like if you give a positive indexing, it will traverse from left to right, whereas if you give negative indexing, it will traverse from right to left. Now you cannot index by a float number. You cannot say a 2.0. You cannot index a list by a float value. It should always be an integer value, right, like this. Now if I want to slice a Python list, what I'll basically do is, since I have 4 terms, I'll just directly write a from right. So the indices for these boundary items are 1 and 3 respectively. But if the ending indexes is n, then it prints items till index n-1. So if I'm writing 3, it will just print the index from 1 to 2 and not consider the third item, third index basically. Right, so this is how I can slice a Python list and save it somewhere else. Also, as I said, a list is mutable. By saying mutable, we can basically add a particular value inside a list and also remove a particular value from the list. In the same way, let's again say my particular values of list A are Python 2 3.0 false. So I can basically, it is possible to reassign a value and delete individual items as well. So we cannot directly assign a value to a list, but I can change the value to a list by its index. Let's say I want to change the third position, which is my false, to true. If I see it got changed, right? Now if you want to delete a Python list, I'll just directly write del and a. If I nothing is defined. right? Let's initiate the list again, and let's add a value to the list, saying with the string, right? See, so it is like a cube. It will always come in the very last thing. Now tuple is a sequence of immutable Python objects. So it is the opposite of list, but similar to list somehow. So when I say immutable again, it means if I define a tuple, it cannot be modified, just how we appended a value or remove some value like that. We cannot do that in a list basically. And a tuple is signified by a parenthesis. So if I say my tuple 1, seed 1, comma 2, comma 3, let's say I'll just 2.2 files. It is completely similar to list. Only thing is it doesn't have any append thing. So it is immutable basically. But you can access the tuple in the similar way how you do it with a list. You can iterate over it and fetch the value out of it. Right. Now the third most important thing is a dictionary. Now about dictionary, when we say about dictionary, let's think of it as a real life dictionary. What is it used for? It holds word meaning pairs, right? Likewise, a Python dictionary holds key value pairs, right? So it is basically signified by, let's say, take one curly brackets, and you just always have to write the key value in quotes. I'll write, let's say, key for that colon. It can be a list, it can be a tuple, anything. Let's understand it. 1, 3. It can have multiple keys basically. This we can assign a tuple. Right. See, now if I want to access just the key pair, I'll just write key and I'll just get the values for the key. If I want, yeah, see, I got it. So this is it about dictionary. Now coming on to the another one, the last one is set. Now this is, I would say, this is one of the most important data structures. A Python set, let's say, is a slightly different concept from a list or a tuple. A set in Python is just like the mathematical set. It does not hold duplicate values and is unordered. However, it is not immutable, not like tuple. So a tuple is just like a dictionary. A set is defined as something like this. So let's say if I have, this is basically my set, right? See, it has organized me, it has given me in an ascending order. Now if I duplicate some values, it will also give me according to it, right? As you can see, it arranged the elements in an ascending order. So since a set is unordered, there is no way we can use indexing to access or delete set elements. We won't be sure like which element will be organized where. We don't know for sure. So then to perform operations on it, Python provides us with a list of functions and methods like discard, pop, clear, remove, add, and many more. Even functions like length and max also apply on sets. So length, max, and min are something that can be applied in list, set, tuple, everything. that we saw right now. It is just to see what is the length of my string, what is the length of my list, what is the length of my tuple, just to understand context of it, what are the type of it, and everything about it. So now most of the time code should be written in such a format that it is very easy to understand on its own as we walked by so far. However, if you want to include a piece of information to explain a part of your code, you can just simply use the hash sign and just write something like declaring a set, and I'll just say my set fun, right? So a line of text preceded by a hash is called a comment. Now the machine does not run this code, it is just for humans to read. Whenever a line has a prefix hash, it will Python will just understand that it is a comment and it doesn't have to be considered as a part of a code. So when you look back at your code later, comments may help you figure out what it was intended to do, you know. So it happens a number of times that you write a logic in a particular project, or you work in a particular project. After that, in a while, when you want to share that particular piece of code, or even you want to understand on your own after months or years, you just need to understand, or you'll just basically forget what was the logic that you applied over there and what you used over there. So for that, it is very important to provide comments on each and every line. So comments can be added in just a single line or even in multiple lines. So for multiple lines, what we can do is we can just write something like declaring a set, something like this. So this is how we can also write multiple line comment. So here we can just write hello there to see it, right? So if you see over here, this is also a multiple line comment that can be added. So this is what a doc string also looks like. You can write this inside a function just to understand that it is a document of that particular function, as how it starts with. A good practice for everything like that is, let's say I have a function C. I'll just give an indentation and write something like return A or return 1. Alright, and this is just a doc string. It just tells you about the entire function, what is going to happen. So a better way to this is, what are the input variables, what are the output variables, and what is the action that a particular function, in this case func1, is performing. So we'll study about functions and everything about it going forward, but this is all that we need to know right now. So this concludes our lecture about indentations, variable assigning, how data is stored, how different types of data is stored, let it be integer, float, or even string. What are comments? What are different statements? How are different arithmetic operations written? And this is what covers, and this is the very basic part and a very important part, I would say. So in the very next lecture, we would cover pandas library and Python. So this is where this lecture comes to an end. So just to wrap this entire lecture, what we learned about in this lecture is why indentations is important, different types of values, how to print different types of data types together, how to store different types of data types in a particular variable, the types of different values, let's say integer, float, string, how to reinitiate and how to reassign the values to a single variable, how to store different types of values and even similar kind of values in different formats like list, dictionary, set, tuple, how what is the difference between those, what are the characteristics of each one of them, and what is the importance of comments. There can be two different extensions to a Python file. One can be an ipynb and another one is a .py file. So .py file is a very basic file that can be opened in any other format, but when it comes to .ipynb, it is just inclined towards Jupyter environment itself. So when we open a .ipynb file in a normal notebook or any notebook editor, what we'll see is it is saved in a JSON format. So everything that we do in Jupyter Lab or Jupyter Notebook, in anyone's case, the settings behind it, the functions, the comments, everything is written in a JSON format in the basis of cells. So it is stored in the cell format and not the direct format as we can see in a .py format. So we'll cover this in the next lecture as well. So thank you again, and thank you for watching. So if you have any questions or anything related to it, let me know in the comments below. So like, share, subscribe if you think this video is helpful enough.